All right, so here I am, FrameCAD Detailer. For this class, we're going to be mostly using FrameCAD Detailer. We're not really going to use structure, but I've given you the license information if you want to explore structure, but you're also not in my FrameCAD Studio class, you can go ahead and do so. Okay. If you want to learn a little bit more about FrameCAD structure, I would highly recommend taking the FrameCAD Studio class next semester, and you'll get to learn how to do a two-story house that will get structurally engineered within the software. So with that, open up FrameCAD Detailer. I'm running version 5.3.2.0. One of the first things you want to do, if it doesn't automatically prompt you for it, is go to the Help drop-down menu, License Information, and you need a license to run this software. Okay, so hit Show License, go to the Online tab, and here's where you're going to put your license serial and your secret key. The secret key changes every single semester. It's meant only for my students in these classes during that time. So put those two things in, put in your email, company should be Orange Coast College, and then go ahead and agree to the agreement and then sign in. So I've already done all that. So now we're going to go ahead and start creating our machine setup. What our machine setup allows us to do is it allows us to tell FrameCAD Detailer what machine I have, what machine do I have in my possession, and also what type of tools is already loaded onto that machine. Okay, and then plus a couple of other things that are super specific, like what are the tool lengths, what are the clearances, and we'll get into that. The first thing we want to do when we're affecting our machine setup is we're going to go to Edit, we're going to go to Options. We have 4 different tabs here: CAD, General, Fonts, Stick Defaults. CAD is where you can play with the interface and the colors of how Detailer looks as a interface for you. Fonts is where you can preload a couple of different typefaces for different scenarios, such as your plan view, build, feature, application view. Stick defaults, these are all the nicknames for all of these different types of stick, such as a bottom chord, bottom plate, brace, head plate, jack stud, and so on and so forth. Each one of those different stick types has a small little abbreviated version, so that way they don't have to write the whole entire thing every time they show you a different stick. And then General. So here under General, I can change my units, and it's important to change your units to metric when you're trying to affect your tools and your lengths of your actual machine. The machine itself was designed in metric units. So therefore we want to switch this to metric when we go to set up our machine. So I've already done so here, and then I'm going to hit OK. And then the next thing I'm going to do is go to Edit, Machine Setups. Okay. Now you might already have a demo machine setup here for you by default. If you do, I would definitely delete it, because we're going to create a brand new one, and we're going to give it all these very specific section setups and tools and lengths and clearances. So I'm going to go ahead and take this one that I've created, and I'm going to delete it. Now I have no machine setups. I'll click Apply to affect our settings. And to get started, I want to choose the correct machine. The machine that we have here at Orange Coast College is the F325IT. It is meant for producing sticks that are 3 5/8 by 1 5/8, basically a 2x4. Now that's the only size section that it can produce. So F325IT, I'm going to click on Create, and now I'm going to walk through this process. The first thing I want you all to do is, in parentheses, add OCC right next to F325IT as the machine's name. Just put OCC. This is going to be really important, especially if you're in one of my other FrameCAD classes. If you're in Studio 2 especially, I'll have you create a special profile for that class. That's not based off of our OCC machine. All right, next, here under tools, I have two categories, fitted tools and available tools. These are all the different tools that are available with various different FrameCAD machines. The F325IT is one model. If I click on this drop-down menu and scroll down, you can see all of the different models that they have, from either a single profile machine all the way up to a multi-profile machine, all the way up to a truss or joist machine. They're all here. These are all of the different possible tools that you could load up into your machine. Now, just because they're here and available, moving any of these tools from available tools to fitted tools won't suddenly allow you to magically start using those tools. What we want to have in the category of fitted tools is exactly what is fitted onto our machine, right? The actual hardware itself, the actual punches and die cuts. So we can't just add whatever we want. In fact, we should remove what we don't have. We have all of these four up top that are grayed out: dimple 1, lip notch, swage, and a web notch. That comes standard on any machine. But flange chamfer, hole, notch, and service hole, those are all optional. We do not have a service hole fitted tool, so I'm going to select service hole, and I'm going to click on this little right arrow to send it from fitted tools all the way to available tools. And then I'm going to select bolt hole with web holes. I'm going to hold control. I'm going to scroll down, and I'm going to also select long service hole. I'm holding control as I do this, and then web hole triple. So I've got 3 items in the available tools column that I want to send over to the fitted tools column. So I'm going to click this little left arrow. Now it gets organized onto the left-hand side. And then the next thing I can do is I can navigate to tool lengths. So tool lengths, these are the actual dimensions of the tool output itself. The only way to know what this information is if you look at your detailer profile drawing, which comes standard with every machine sold. So what this is shop drawings of the various sections that can be produced with your machine. With my F325IT, I can produce a C section. This right here is called a C section, and I can also produce this one here, which is a U section. Okay, this is a C because it's got these little hooks over here, and it kind of looks like a C that's laying down, right? And then obviously the next page shows the U section, which looks exactly like a U. Okay. So those are the 2 different types of sections I can produce on this machine here at school. The C section is also called an S section sometimes in the industry. So what are we looking at? The first 2 drawings on the top left show a section BB and section AA. So section BB is what's called a section cut, which cuts through this elevation here. These arrows indicate which way we're looking, and that's what this drawing looks like. If we were to slice right here, that's what section BB is. Okay, and it's cutting through there because it's swaged. And let's see. All right. So that's section BB. Section AA is also a cut, but it's cutting way over here, not cutting through the stick at all, really producing an elevation, right? If you're an architecture major, you totally understand what's going on here, right? An elevation and a section cut. This is the plan drawing This is an elevation drawing, right? They're correlated, so if you see a service hole here in plan, right, you might be able to see it here in elevation. Here's a flange cut in plan, and here it is in elevation. Here's a lip cut. We have a web notch, flange hole, right? Flange hole only appears on the flange, which are the side pieces of the section, so you wouldn't see it in plan. You got your web hole with bolt hole. That only appears in plan view because it's occurring here on the web of the stud, but not showing here in the elevation. And then the swage. The swage here, as shown by this elevation drawing, this plan drawing, and this section drawing, okay, is showing where the stud gets squeezed. Right? That's a swage. Okay. That's why this stud looks a little squished, right? Kind of squishes here on the sides. Still a very rigid stud. And then we have a left flange. So let's talk a little bit about the geometry here, the vocabulary. This bottom part, that's our web. Okay. This is our right flange. Our left flange is on the left-hand side. And then these two little pieces up top, those are your lips. Okay. So understanding all of that vocabulary helps you understand what tools you're observing. Right? These holes that occur in the web of the stud, those are web holes. The holes that are occurring here on the flange is a flange hole. Web notch, lip cut, flange notch. The whole flange is eaten away. Okay. And then we have a couple of other tools, such as chamfer. This is what it looks like in plan view. And then this is what it looks like in elevation. So when the machine produces a chamfer, usually it cuts it right there where they meet to produce two different sticks with those chamfers on it. Usually those are for angled pieces. And then one of the most favorite ones, the dimple, right? You got your little dimple, which is a pre-drilled hole that has a standard diameter of 0.15 inches. And then it's also countersunk. So that way when you go to attach your sheathing, your drywall, it doesn't have a little bump in it from the screw head. Right. So those are all the different tools. Here you can see as a diagram in 3D, as an isometric. But all these measurements that we can see here, those are, this in plan view, these are our tool lengths. So for a swage, the tool length is 55. So 2.17. 2.17 is the measurement in inches. Whenever you see values in brackets, those are those values in inches. When you see those values without brackets, that's your metric or millimeters equivalent. Okay. Remember, we're doing all this stuff here in using the metric system, so we're going to want to use these numbers here, not these ones above. Okay. All right, and then let's talk about section AA. All right. Section AA has no swage, and therefore shows us the overall dimension of our section. Down below in our web, it's 3.625 inches, which equates to 3 5/8. On the left flange, 1.625 inches, or 1 5/8. And then our lips, 0.5 inches, 0.5 inches. Okay, those are even. Now here on the right flange, it is not 1 5/8. This is 1.7 inches. It's almost 1 3/4 inches. Okay, so why? Why do I have a left flange that is 1 5/8 and then a right flange that's just a little bit bigger? The reason for that is because this is what's called a boxable section. Okay? If I were to have two of these sticks, I took one of them, oriented it just like this, took the other one and sandwiched them two together where it's open face to open face, I would have what's called a boxed section, which creates a very rigid, strong post, basically. Almost like a 4x4 post. Okay, so that's why the right flange is taller than the left flange. Just ever so slightly, but if you were to look at one of our steel pieces, you'd see it. And it plays a very important role. All right, I think that's it for that one. And then here's our U section. Similar characteristics, except there are no lips, right? A U section is an unlipped section, okay? No half-inch lips up above. So why would we want this option? Typically, with like H steel, you're either buying it at a box store, or you're buying it and creating it yourself using FrameCAD. When you buy it at a box store like Home Depot, Lowe's, any one of those places, you have to buy two different kinds. Okay, one is called the track, which would run your bottom plate, or it would be your top plate, and then the rest are called sticks, which are all of your vertical ones. So all of your bottom and top track have no lips, right? So that way your sticks can just fit perfectly right into them, and then you can attach them. We don't have to use something like this here with FrameCAD, because FrameCAD can produce lip cuts, right? If I go back to this other drawing, the reason for the lip cut is so another stick can be inserted exactly at that point, right? So I really just need to stick with my C or S section. But if I need it, I have a U-shaped option. All right, and then this is just a flat pattern. We're never going to be able to produce this with our machine. This is more diagrammatical, if anything. And the reason why we can't produce this on our machine is our machine has 6 rollers, right? All the steel goes in flat, and because of those rollers, it turns into its C or S shape, okay? Or U shape. So there's no way we'll ever get it flat like this. Not that we ever need it that way. So with all that information, I can now navigate back to my machine setup, and right here for left flange, I'm looking for the length of that specific type of cut. So if I zoom in, it's talking about the flange cut, which is right here. My flange cuts are 48.3 millimeters. So going back to detailer, my left flange 48.3, right flange 48.3 as well. Okay, my lip notch is this one right here. It says lip cut, tool number 2, at 48.3 millimeters. So I'm going to change that to 48.3. Thank you. And then we have our swage. So let's go back and find our swage. The length of a swage is exactly 55 mil, which this already is. And then our web notch. Web notch is 48.3, so I can make that adjustment here. All right, those settings are all procured. I can move on to the next tab right here under General. Now with General, all I need to do is I need to change back-to-back tooling. I'm going to change it to bolt. What this part is it's indicating if I have a truss and that truss is going to attach to a wall or another truss, where does that connection occur? And I want it to occur via a bolt connection, so I can bolt them together. But these are my other types of connections. I can connect them via the webs of studs with a center priority, center only. For now, just know bolt is all we need. I'm going to keep this at 0, minimum tag length of 20. Minimum tag length is a really interesting one. If I were to put two flange notches, let's say for example, next to each other, if the distance in between those two flange notches is less than this number here, minimum tag length, it's going to put one flange cut there instead of the two that I want. Okay, which keeps me from putting too many of these flange notches in a row, weakening that piece of steel. It's going to average it out and say, well, I can't give you all these flange notches in a row, but instead I'll give you one in the center of each of the two. It's really good for the machine, otherwise it could jam it. I'm going to have place extra flange chamfers checked, 3.00 plate differential, no extra flange holes, standard fastenings, and then this one's grayed out. Next tab is clearances. So looking at clearances, I'm going to make sure that bolt hole to end is 20. I'm going to change the end clearance reference to inside web. 50. Got 2. Chamfer tolerance is 2. Web hole to end is good. All right, don't worry about these for now. Just make sure you use the same values. I'll share these with you later. And then we'll go to boxing. To be safe, after you affect some of these values, go ahead and hit apply. Otherwise, if you accidentally hit escape or cancel, none of these settings will stick. So now that we're in boxing, I want to make sure that I've got this set to 2, 200, 500, 10, 500, and 100. So these default settings will work for us. And then the next thing, all the way back to the beginning, section setups. All right. So here's that familiar drawing, right? Similar to section AA. The first thing I want to do is you should only have one section in this list here. Okay. In this list, I can have multiple different section setups, meaning I can, depending on what machine I have, I can make it produce different shapes, right? We already know I can produce two shapes, right? An S or C section and a U section. So I'm going to need a minimum two different section setups. But besides having a variable in the dimensions of my section, I could also use different material, right? And the different material could be thicker from one material to another. It could have different material properties and finishes. So I can add in all of these different instances based on the type of section I will likely produce with my machine. If I was a manufacturer who does many different jobs for many different clients and architects and structural engineers, I might need to have a thicker gauge material sometimes, right? I might need to use the thicker stuff. Sometimes I might just need the thinner stuff, right? An interior partition wall typically does not have the same structural strength as an exterior wall, right? But there's no need for me to have super structural interior walls, especially if they don't bear load. And I definitely can't have walls on the exterior that are rated for non-load bearing, right? Because those exterior walls typically are bearing load. So I can have multiple sections. So what I'm going to start doing is I'm going to set each one up, starting with the section name. When it comes to naming conventions, we do it as the standard. We'll say 362 362S 162 and then dash 27. Okay, 27 has to do with the gauge, right? S has to do with the shape. So here in this drop-down menu, I make sure I have S selected. And then I come down here and I use my profile drawing to help guide me by putting in these measurements. So my web is this part here, 92.1. My left flange is 41.3. My right flange is 43.2. My lip is 12.7. Remember, these are millimeters. Okay, there we go. There's my typical S section. And now, as I go through the rest of the properties, I want to just check on these different things here as well. So here's my dimple 1 height. If I navigate back to this drawing, this area right here is showing me where my dimple is, and it's also showing a dimension from the bottom of the web of the stud to the center line of that dimple. So 21.6 is my dimple 1 height. My flange hole height, and I want to find that somewhere. Let's see, where's our flange hole? Here's a flange hole right here. The height of that flange hole from that same datum, that bottom web, is 29.7. Triple web hole spacing, I believe, is already 17. Here's the spacing from the center of this little hole to the center of this bigger hole. This is my bolt hole, where typically on a foundation you would have the rebar or anchor bolt coming through the concrete, and this allows you to put that anchor bolt through the bottom plate, and then these are some extra fasteners to help fasten that down. So 17 millimeters is my spacing. And then my material properties. So for material properties, BMT basically stands for the thickness of the material. So for BMT, I'm going to set this to 0.69. It is measured in mils, so 1/1000ths, and I'm also in millimeters, so 0.69 is really the 1/1000ths. It's 0.0069 is the thickness. The steel spec, here are your different options. And then your material grade, SS50. These are just the standards that we use here at OCC. If you're your own manufacturer, you might have way more choices than this. And then the next thing is export compatibility. And if you see it says RF section and it says not compatible, just hit this little uncheck button. Click on this drop down menu. Oops. Uncheck this one. And what we want to do is we want to find the correct section, which is going to be a 92. This is a long list. 92.1S43.3, I think. S41.3. 92. Unfortunately, this is not in order. 92.1 S43.41.3. There we go. All right, and then go ahead and hit this little check mark. This will self-populate, and that is one section. This is one option that we'll have. Now we just need to add a couple other ones that use a different thickness. So with our machine here, we typically run 20 gauge material, but I can run all the way down, I can run as thick as 18 gauge or 22 gauge. So when it comes to a gauge, the higher the number, the thinner that material actually is. Okay, so 18 gauge is thicker than 20 gauge. Okay, 20 gauge is thicker than 22 gauge. So 22 is actually the thinner one. So I want to have profiles that match those different thicknesses. So now I'm going to select this one that I just made. Let's expand this just a little bit. And I'm going to say copy section. I'm going to select that new copy. I'm going to go down to section. and take off the little 1 in parentheses here. And instead of 27, my BMT is going to be 33. Values stay the same. I'm going to change the material properties of the BMT to 0.84. And then I'll hit apply. Just hit apply frequently. Now I'll take that new one I just made, make another copy. And I'm going to go to section. I'm going to delete the 3.3. And instead I'm going to just say 4.3. Keep all that the same. Go to the material properties and change that to 1.09. All right. So now I have all 3 of my S sections of different thicknesses, different gauges of metal in the S or C section. So now all I need to do is create my U sections. So to do that, I'm going to select any one of them. I'm going to say copy section. I'm going to select that new copy. And instead of an S, I'm going to say U, because I'm doing the U section now. I'm going to delete the 1 in parentheses. I'm going to leave the 43, change the shape to U. And now I'm going to start to affect these settings. So going back to my profile drawing, it's page 2. Here are my different dimensions. Left is 51 mil. So left flange is 51. Right flange is 52.9. And then my web is 92.1. Stays the same. And now that's up to date. Now I need to do that for the other sections. So I have 2 of the 43. I'm going to take the 33 and copy that. And take that copy, switch out this S for a U. Change the shape to a U. And then I'll affect these values here. Right is 52.9. Left, 51. Okay. And then the last one is going to be my 27 BMT. I'm going to copy that one. I'm going to rename it, put a U there. Take off the 1. Change the shape to S. This was 51. And the right was 52.9. All right. Now I have 6 different sections to choose from when I go to create things here in Detailer. Now that I've finished creating all of my different profiles, it's called F325IT OCC, and hit apply, and I'm going to say OK. And the next thing you need to do is you need to configure your frame types. So I'm going to go to Edit, Frame Types. We're going to start to create a new frame type. So every different type of frame in Detailer is going to be categorized or classified as any one of these options here. It's either an external wall, internal wall, a truss, joist, miscellaneous, ceiling panel, roof panel, or floor panel. Okay. Basically what it boils down to is whether it's vertical, up and down, like a wall, or horizontal, like a floor, or slightly pitched, like a ceiling or roof, or if it's a truss or a joist. So you're going to want to you're going to create a new frame type, choose external wall, make sure that for default machine setup, it says F325IT OCC, your one and only machine setup. If you see 2 options here, go back to your machine setups and delete that demo machine setup, or delete whatever you may have created. If you have 2 copies of the OCC one, you really don't need that, and you're only going to confuse yourself. You just need 1 for my class, for this class. All right, and then you're going to hit create new frame type. Okay, so I've successfully created an external wall frame type. Now for the next one, I'm going to choose internal wall. Make sure I use the same correct machine setup. create new frame type, truss, correct machine setup. And I'm going to do it until I get all of them. This part's super easy. Oops. Ceiling panel. If you make a mistake and make too many of one, you can always go back. I think I did a ceiling panel, roof panel, and floor panel. So it looks like I have 2 joists, right? One has parentheses 1. I can delete that second one. I'm going to delete selected. So you should have 1, 2, 3, 4, 5, 6, 7, 8. 8 different frame types. This color here, where it says VRML frame color, don't worry about it, but when we start to do our 3D previews to check and see if everything we've designed looks correct, each one of these different frame types typically will have its own different color, just so you can tell between all of these different frames what is what. They all have different colors. Okay, once you've got that, go ahead and hit apply and hit OK. So now we've got our machine set up. We've got our frames created. Next, I'll show you how to export this setup. Right? Let's pretend we all worked under one manufacturing company. We have multiple machines. Am I going to have every single employee go through this whole entire process? If I did that, would everyone get it all 100% correct? Probably not, right? Somebody's going to mess one tiny little thing up, and that could mess up the whole entire production, right? Instead, what I might have is my trainer might actually go through, get those settings done, and then I'll have them export, file export, frame types, machine setups, and steel setups. So we're going to click on that. We're going to come upon a dialog box that looks like this. Just like we did earlier, we're going to select all of our frame types that are available. We're going to move them over to the to be exported side. My one and only machine setup that these panels or these frame types are dependent upon automatically came over as well. Now I can say export, and it's really important that if you get all these settings correct, you put this file somewhere very important where you can find it again later, right? Should you ever mess up any of these settings, you can always delete those machine setups and those frame types, come back and reload them and start over, start fresh. So I'm going to leave it right here. I'll put a little 2 on it because I already did this exercise. And then I'm going to say save. Does it already exist? Sure. All right. So now that I have it's called a SUPS file. The file type is .sups. Now that I have that all configured, I'm going to test it out. I'm going to go to Edit, Machine Setups. I'm going to take my machine that I just spent this last 38 minutes creating. I'm going to delete it. Yes, I'm going to delete everything. I'm going to hit OK. I'm going to make sure all my frame types are gone. Yeah, they're all gone. There's nothing there. So now I'm back to square one. So now, if I wanted to import all that, File, Import, Frame Types, Machine Setup, Steel Setups. Here is where I saved it. Actually, this is not where I saved it. Let's go FrameCAD. Let's go to Workshop, Machine Setup. All right, here it is. 250908 OCC FrameCAD Machine Setup.sups. Okay, I'm going to bring that in. Import finished. Now let's see what happened. Edit, Machine Setups. Got one machine set up again. All of my 6 profiles here. Edit, frame types, and here are all of my different frame types. Okay. So the exercise I'm going to have you all do is you're going to replicate all of this entire exercise from start to finish. And what I have for you is your very own little copy of our detailer profile setup. I'm going to go through this exercise. You're going to identify all this information. If you navigate to Canvas, I've also uploaded, oops, let's go to Workshop. Let's go to modules. Right here under week 2, let's go ahead and publish this. Publish. Okay. Only available to students with the link. Okay, I think it's published. Okay. FrameCAD profile drawing F32163, W362, F170162. That's this PDF. So if you prefer to look at it through this PDF, or if you want the paper hard copy, you can grab this instead. All this information is here. Once this video is done with the publishing, I'll go ahead and upload it to YouTube so you guys can watch it back. This will be due at the end of the night, and then I'll show you what your next assignment will be due next week. Okay? Any questions? Were there any questions about any of the Rhino stuff? Yes.
I didn't do the curves. I did something else because I already know how to use Rhino. That's okay.
Sure. That's okay. Any other questions about the Rhino assignments? Was it hard? Easy?
Put my question in here.
Oh yeah, if it's super specific for one of the videos I already have uploaded, just put it right there. That would be perfect. Yeah. Okay, cool. I'm going to keep on sprinkling some more of those Rhino exercises. It'll make more sense later on why I'm having you do this Rhino stuff. It's because we're going to start designing for FrameCAD, right? And we're not all going to be making buildings for the rest of the semester. Instead, we're going to make some cooler, smaller, finer tuned items and objects such as furniture. And to do that, we're going to use a design software. We're going to use our designer skills, hence the notebook, right? You guys should be able to draw these things. And that'll be part of your assignment due next week. Is there's a sketching portion to it. So Rhino is going to be for designing these cool things. We're going to 3D print these cool things. Before we even go and waste any of my steel, we're going to 3D print small little copies of it instead. Right? Save tons of money. All right. I'm going to end this session. If you guys have any questions, let me know. You guys are more than welcome to work together on this. Put all your heads together. All right.